Physics has rules. One of the most basic rules is this: pistons are round. Cylinders are round. If you try to make a piston any other shape, it won't seal, it will leak, it will explode. But in 1979, Honda didn't care about physics. They cared about winning. They built an engine so complex, so expensive, and so radically different from anything else on Earth that the engineers called it a nightmare. The rest of the world called it a miracle. This is the story of the oval piston, the technology that Honda spent millions to perfect, only to bury it in a grave, never to be seen again. Why did they build it? And why will you never ride one? The problem, the two-stroke enemy. To understand the oval piston, you have to understand the war Honda was fighting. In the late 70s, Grand Prix racing was dominated by two-stroke engines. Yamaha and Suzuki were winning everything. Two-strokes were light, simple, and powerful. Honda hated them. Soichiro Honda, the founder, believed in four-stroke engines. He believed they were the future of engineering. He wanted to win the world championship using a four-stroke. But there was a math problem. A four-stroke engine only makes power on every second rotation of the crankshaft. A two-stroke makes power on every rotation. That means, theoretically, a 500cc two-stroke makes twice the power of a 500cc stroke. To catch up, Honda needed to spin their engine twice as fast. They needed more valves. They needed more cylinders. They effectively needed a V8 engine to beat the V for two. But the Grand Prix rulebook had one strict line: maximum 4 cylinders. Honda was trapped. They couldn't build a V8. They were stuck with a V4. Or were they? The loophole. The V8 disguised as a V for Honda found a loophole. The rules said you could only have 4 combustion chambers. But the rules didn't say those chambers had to be round. So, the engineers asked a crazy question. What if we take a V8 engine and merge the cylinders together? Instead of 8 small round pistons, they created 4 giant oval pistons. Look at this. This is the NR500 piston. It looks like a Spam tin. Because it was oval, it was wide enough to fit 8 valves per cylinder. Not 4, 8. It had 2 connecting rods for every piston. Mechanically, it was a V8. Legally, it was a V4. It was a brilliant cheat code. It allowed for massive airflow and incredibly high RPMs, over 20,000 RPM. But there was a reason. Nobody had ever done this before. Machining a round hole is easy. You just drill. Machining an oval hole to within a fraction of a millimeter is nearly impossible. But the real problem was the seal. Piston rings are springs. In a circle, the pressure is equal everywhere. But in an oval, the rings have to bend around tight corners. At 20,000 RPM, the rings would flutter. They wouldn't seal. Honda's test engines didn't just fail. They destroyed themselves. Connecting rods snapped. Blocks cracked. The engineering team worked 24 hours a day. They had to invent new machining tools just to make the parts. They tried hundreds of different ring materials. Eventually, they got it to work. But when they took it to the racetrack, disaster struck. The debut was at Silverstone in 1979. The world was watching. The exotic oval piston Honda rolled up to the line, and it wouldn't start. When it finally did start, it was slow. The engine was heavy. The chassis was experimental. The press was brutal. They nicknamed the NR New Racing, not as New Racing, but as Never Ready. For years, Honda tried to make it win, and while they eventually got some power out of it, they never won a world championship. The two-strokes were just too light and too developed. Honda eventually gave up on the oval piston in racing and switched to the NS500 two-stroke, and they won immediately. The oval piston seemed like a failure, a billion-yen mistake, but Honda refused to let the technology die in shame. 10 years later, in 1992, Honda dropped a bomb on the street bike world. They released the NR750. This wasn't a race bike, it was a road-legal motorcycle that you could buy if you were rich. It used the famous oval piston technology. It was a V4 with 32 valves. It had titanium connecting rods, carbon fiber bodywork, a first for a production bike, and a digital dashboard that looked like a fighter jet. It cost $50,000 in 1992. Adjusted for inflation, that is over $110,000 today. It was the Bugatti Veyron of motorcycles. Only 300 were ever made. It proved that the oval piston could work on the street. It was smooth, it was exotic, and it was stunningly beautiful. So, why don't we have oval pistons in our CBRs and Ninjas today? The answer is simple: economics. The oval piston solved a problem that no longer existed. Honda built it to cheat the racing rules. But on the street, there are no cylinder limits. If you want more power on the street, you don't need oval pistons. You just make the engine bigger. Manufacturing an oval cylinder is 10 times more expensive than a round one. The piston rings are a nightmare to source. The complexity just isn't worth it for a 5% gain in efficiency. Even in MotoGP today, Honda uses round pistons. The materials have improved, the revs are higher, but the shape has returned to the circle. The oval piston remains a technological dead end. A beautiful, expensive, fascinating dead end. The Honda NR750 stands as a monument to stubbornness. It is what happens when engineers are given an unlimited budget and told to break the laws of physics. It didn't change the world. It didn't take over the industry. But it showed us what is possible when you refuse to cut corners, or, in this case, when you refuse to cut circles. If you liked this dive into impossible engineering, click this video here. We uncover the story of the engine that was banned because it was too fast.